All right, guys, looks like we are live, and I will give it a few moments for anyone who happens to be awake at 9 a.m., which is a normal time to be awake at, to log in. Let's see how many people have checked in for attendance so far today. Let's see. Looks like I got 5 people. So there should be about 5 people that are willing to attend this. And let's see here. At the moment, there were 4. Okay, so 3. Okay, so of all my students, I have 3 of you that seem to be awake and logged in at 9 o'clock. A little sad, just saying. But anyway, today we are going to be starting the next unit. Now, yesterday during that video I made, I mentioned we were doing Unit 2, but I made a miscalculation. We're actually going to be doing Unit 7. So I apologize if that screwed anybody up, but we're doing Unit 7. I forgot about Unit 7. After Unit 7, every unit we have for the rest of the course is going to be math-based. So I say that to the end. So that's that, okay? So we're going to be doing Unit 7, just so you know, and it says so in the title of the video. We're going to get started on this unit. So this unit is, sorry, I got my windows open, and it's real windy out today. I don't know, is it windy down by you guys too? What's up, Connor? I don't know. Whatever. The weather is the weather. So, how's the audio? Is the audio okay? Sound good? All right. I messed with some of the settings for the stream. I tried to cut down on some of the delay and the latency of the video, so that might be making a difference in terms of quality and what have you. All right. We got Kaylin. Good. And Connor says the audio is good. Okay. Very good. All right. So let's get moving here. Unit 7. No math in Unit 7. That's really going to be all that difficult. We are going to be primarily doing chemical reactions. Okay, this is going to be difficult to do not in class, because in class I would have done some demos and showed you some examples. But we're going to do the best we can. So in this unit, let's stick here. All right, so this unit, Unit 7, is going to be first balancing equations, okay? And then you're going to determine what kind of reaction it is. I'm going to give you 5 categories and all the details and everything. Once you have a thorough understanding of the details of those 5 categories, you will then start predicting products. So at first, you're going to have the reactants and the products given. Then you're going to tell me what kind of reaction it is and follow the patterns. Then I'm going to take the products away, and you have to figure out what the products are. That's called predicting products. All the while, we're balancing every equation you come across. And then there's some other details that we have that we got to get to, but that's the gist of it. So learn how to balance, learn how to tell what kind it is, and then predict the products, and then some other stuff. Josiah, what's up? All right, so let's, how can we do this without an actual PowerPoint? So we are going to be learning a couple of keywords today, okay? So if you have a notebook, I would highly recommend having a notebook and maybe jotting some notes down along the way. This is the first unit that we're doing that is 100% online. So we're going to do the best that we can. I'm going to do best I can. You guys are going to have to step up and do the best you can as well. Anyway, here's the deal. You should have a notebook or something to take notes with, okay? So I'm kind of stalling for you to do that. Get a piece of paper, get a pen, get something. Now, you can go back and rewatch this, but it would just make sense to follow along and take notes. Okay, having said that, I'm going to give you some keywords, okay? So write this down. I'm going to give you a definition of product and reactants, okay? We're going to start with reactants. Reactants are the chemicals that you start with in the chemical formulas of the reaction. That was very wordy. Let me rephrase. Reactants are what you start with in a chemical equation. Products are what you make. So let's switch cameras here, and we'll go to an example. So let's get rid of this paper here. All right. All right, so you've seen this before. You've seen chemical equations and chemical reactants. Let's get rid of. We don't need the periodic table just yet, so let's get rid of that. Okay, so your very, very basic chemical equation is going to look something like this. Let's say I have sodium plus chlorine. That's going to make sodium chloride. All right, now there's some stuff going on here that you need from the previous unit, okay? Do not forget all the naming, the crisscross, all that stuff, okay? So for instance, let's go through this. This is your first example of a chemical equation. I have sodium, whatever, nothing fancy going on there. I have chlorine. Now chlorine is a diatomic. It's one of those 7 elements that come as a pair. So when I say chlorine, you should just be thinking Cl2. Now, when I have sodium and chlorine together, I'm going to make sodium chloride. So what I ended up doing was the crisscross between sodium and chloride. It's not all that difficult. It might seem a little foreign at the moment, but it's not going to be too bad for too long. So anyway, these two here, these are your reactants. Okay? This is your product. So to recap, your reactants are what you start with in the reaction, and the products are what you make after it's over. Think of this as like a before and after the reaction. This arrow simply indicates that it's going in this direction, and it always points towards the products. So we got the reactants and the products spelled out. You've seen a chemical equation. That's basically the first part of the whole unit right there. Now let's get into starting to balance this. Okay, I'm going to just balance this because I just want to get right to the answer right away, and then you can see how I did that. Okay, so this is how you would balance this one. All right, might not make all that much sense, but if we look at it before it was balanced, it's just Na plus Cl2 makes NaCl. Right, this is what's happening. I have 1 sodium to start with. I have 1 sodium after the reaction is over. So that makes sense, right? I have the same amount. Remember the law of conservation of mass? Matter cannot be created nor destroyed. So I have 1 sodium and 1 sodium. I didn't just make a random sodium. I didn't lose a sodium. I had the same amount. And that's the whole point of balancing. Here I have 2 chlorines. Over here I only have 1 chlorine. So I need to adjust that because it looks like 1 disappeared. It's not going to just disappear. Whatever I start with must show up in the end. So 2 chlorines here. I'm going to put a 2 over here. Okay. Now I have 2 chlorines. But I also have 2 sodiums. So I messed that up. I got to go back and fix that. Let's put a 2 here. All right. So that's basically, excuse me, that's the basis of this entire first section of the unit. And if you guys have any questions as we go, feel free to ask these questions. Or, like I said, I messed with some of the settings, so there might not be as big of a delay, and I could probably get to you a little sooner. So let's look at a couple examples. All right, I'm going to turn this paper here, and I'm just going to make up a couple examples. You're not quite sure where this is coming from just yet, but you will have an idea. I'm doing the crisscross as I go and everything. Once we're adept at balancing equations, we're going to start looking at these patterns that I'm going to show you, and you'll be able to figure out where I'm getting the products from. But for now, you're just trusting me what the products are. I hope that makes sense. So let's say I have H2 plus O2, and that'll make H2O or water. Okay? Let's take an inventory. That's usually the first step, all right? You kind of figure out what you got, and you keep track of that. So I have 2 hydrogens here, and I have 2 hydrogens here. Well, that checks out. That seems okay, right? On the left, I have hydrogens. On the right, I only have 1 oxygen. So I'm going to take a 2 and put it there. This now gives me 2 oxygens. But I also now have 4 hydrogens. So I have to go back over here, put a 2 there. Now that's balanced. I hope that makes sense, okay? Balancing is not all that difficult. It might seem a little odd at first, but you can figure it out. Let's make my face a little bigger here. Hope that makes sense, okay? Anyway, again, you guys have the ability to ask questions. Those who are not watching don't get that ability, and, it is what it is. Okay, so I'm going to do another couple, and then I'll give you one to try on your own. Hopefully you got that notebook and paper ready to go. So let's say I had something like all right, barium oxide will break down into barium and oxygen. Now, oxygen's one of your diatomics, so you got to be aware of that, okay? Can I zoom in on my face so I can make that a little bit bigger? Let's see. Like I said, I'm still trying to figure this out. So, camera controls, zoom. I cannot, for whatever reason, zoom using that camera. Whatever. Let's balance this one, okay? I'm trying to have as much here, but you can still see me. Whatever. All right, so we're going to balance this one. Barium oxide breaks down into barium and oxygen. All right, O2, diatomic. Looks like if we just go left to right and we start picking out some of the elements, we see how many we have of each, and we go from there. So for barium, I have one barium, and I have one barium. So that matches. That's good. I can leave that as is. Next, I have one oxygen and two oxygens. Okay? So this 2 means I got to put a 2 over here. Now, a lot of people are probably thinking, why can't I just put a 2 here and give it O2? Well, the reason for that is because this formula here for barium oxide, the crisscross has already been done. This is neutral. You can't mess with the formula. But what you can say is I need more than one of those whole thing. So don't mess with the formula by putting subscripts. You can't do that. Don't do that. But you can put coefficients here. So I put the 2 here to give me 2 oxygens to match what's over here. Now, when I did that, I also increased my number of bariums. So now I have 2 bariums on the left. I'm going to have to put a 2 there on the right. You guys seeing my mindset? You kind of following along as I think out loud? I hope that makes sense. Give me some sort of feedback if you guys are with me or not. We're up to 6 people, which is good. It's better than 4. If you guys are following along and this is making sense, you got to let me know one way or another. Otherwise, I'm just talking to my computer in my office and I feel like an idiot. So, one more, and then I'll leave one for you to do. I'll give you a couple of minutes and we'll see what happens. Okay? So, let's try... Okay, so Josiah is saying it makes sense. If you guys do have any questions, you have to let me know. All right, let's do a difficult one. Okay, so there's a question. Does it make it 4 oxygens? Well, there's only 2 here before the reaction, and then I have 2 after the reaction. Picture the arrow is like a before and after. Okay, so before is on the left, after is on the right. This is what happens at the very beginning of the chemical reaction. After it's over, these are the products that you've made. Johnson, I hope that makes sense. You only have 2 total ever, okay? 2 here. These are the same 2 oxygens. Again, Johnson, I hope that makes sense. Okay, Kaylin's giving me some feedback as well. Thank you, Kaylin. That's working out good. Okay, let's do another one. I'm going to do a crazy one, okay? All right, good. Let's do sodium phosphate. All right, I did the crisscross, just what we learned from the last unit. And I'm going to react that with, let's say, let's go nuts. Barium sulfide, okay? And I did the crisscross and everything. Now, again, you guys are trusting me about these products. Okay, I'm giving you the products. Soon you will have to figure these out for yourself. okay? Now, there's a couple of tips that kind of happen along the way that most teachers don't share with you. I'm going to give them to you because I was frustrated learning this many years ago at this point. And these were tips and tricks that I was hoping somebody would teach me, but I kind of developed them on my own. So, excuse me, if you have a polyatomic involved, like this phosphate, okay, this will speed things up for you. So let's come up with the products, and I'll elaborate on how the polyatomics help. I got to do the crisscross now because I'm going to be making barium phosphate and sodium sulfide. Can you guys see that okay? Is that showing up on camera all right? All right, now, you got your reactants and your products. Reactants before the reaction's over, and the products after we're done, okay? Let's see. Let's balance this, all right? So I'm going to go left to right. I have 3 sodiums here, right? 3. And I have 2 sodiums over here, the 2. Okay. Now, I can't get this 2 up to 3 by putting any number here. And I can't bring the 3 down to 2. Excuse me. So what I need to do is get them both to the same thing. Let's get them both to 6. Okay? Now, I see an issue already that's starting to happen. So what I want to do is 3 with a 2 gets me to 6, right? A 2 with a 3 gets me to 6. Does that make sense? I now fixed my sodiums. I made them both to 6. You'll see that happen every once in a while. It's a very common thing. Now, notice I have phosphate. I pointed that out earlier. And I have 1 phosphorus and 4 oxygens. What a lot of people who are just learning how to do this try to do is balance the phosphorus and the oxygen. What I'm going to do to speed things up is balance the phosphate as one thing. So it looks like I have 2 phosphates. I have a phosphate with a 2 out front. So I got 2 of them on the left. It also looks like I have 2 here on the right of the arrow. So the phosphates are already balanced. It's done. All right? I don't have to go any further with that. But I do need to fix my bariums. I'm going to put a 3 here. Okay? My barium, I have 3, and I have 3 there. And finally, in the end, I have 3 sulfurs and 3 sulfurs. So everything's balanced. Yeah, it's kind of like the crisscross. The crisscross will be used for each individual formula, but you, again, the whole point of balancing is getting everything to have the same amount before and after the reaction's over. So that was probably on the more difficult side, okay? There are more difficult ones to do, but that probably was thrown at you maybe a little too soon, but it's the same principle, all right? So let's go to a clean piece of paper. What I want to do is later today, I'm going to give you an assignment. I guess I should give you an assignment. What I'll probably do is give you an assignment for tomorrow, okay? I'll put up an assignment tomorrow morning and give you a little while to try that, and it'll be nothing but balancing, okay? So as an example, let's do another one, and we'll see if you guys can start to feel comfortable with this or not. All right, so let's try excuse me. I'm going to put one down. I'm going to let you try it. And the first person who comes back with a comment saying that they got the answer is when I'll start giving the answer, and you guys can all check yourself. If you have to, pause the video, and then even though it's live, you can still pause it, and it'll pick up where you left off. So here's one to try, all right? It's not bad. Let's say I have H2O2, and that breaks down into H2O and O2. This is a very classic example. This is hydrogen peroxide breaking down into water and oxygen. So you're trying this one on your own. If you feel like you need to pause the video, that's fine. But I'm going to stall with some tips until I get somebody telling me that they got the answer, okay? So we have a group of hydrogens and oxygens on the left, and we have water and oxygen on the right. So you have to worry about hydrogens. You got 2 on the left, and on the right I have 2 hydrogens as well. So they seem to be okay at first glance. Oxygens are going to be a bit more difficult, okay? Only because it looks like I have 2 on the left, but how many do you have on the right? All together. You have to worry about how many you have all together, even if they're split up into different compounds. So we have 2 oxygens here. We have 1 oxygen here and 2 there. So it looks like I have 3 total on the right. So you got to worry about how to get that balance. I'm going to give you a moment, and you're trying this on your own. And when the first person comes back with a comment saying that they have an answer is when I'll start showing you the answer, and you guys can check yourself. Again, you can pause the video, okay? I'm not sure how else I could stall, so I'm going to kind of go quiet here for a moment. I'll check a couple things while you're doing that. Okay, Connor's saying that he thinks he got it. Okay, so let's show you how I would solve this. All right, so it looks like I have 2 hydrogens here, 2 hydrogens here, so that checks out already. And then we mentioned that the oxygens were the issue. So 2 and 2, but then I have a third one here. So here's the deal. Or Josiah is saying he got it too. So check yourself, you guys, see what you got. I'm looking at this as, okay, I have an even number of oxygens, right? I have 2. Here, I have an odd number of oxygens. But if I put a 2 here in front, doesn't that now give me 2 oxygens there and 2 oxygens here with a total of 4 oxygens? That makes sense, right? 2 plus 2 is 4. But now I have 4 hydrogens. Well, this works out because if I put a 2 here, not only does it give me my 4 hydrogens that I need to match what I screwed up, but it also fixes my oxygens to give me 4 on the left to match the 4 I have on the right. So this should be how you have the answer. You got 2, 2, and 1. And that's pretty much how you would say the answer. So you would say, what's your answer? Somebody else would say 2, 2, and 1. Okay, so you're just saying what the coefficients are. And did you guys get that? Is that the answer you got? All right, if you got something different, it's probably wrong, just saying, because there's only one right answer here, okay? Let's go for a little bit longer. I do have to set up my live stream for my other class as well, so I need to get that figured out, okay? Johnson, did you get something different? What did you get? Just say the coefficients. I got 2, 2, and 1. So if you give me your wrong answer, no offense, I'll just use as an example of some of the issues you might come across in this, and then why that's not totally correct. So, Johnson, what was your coefficients? Connor says he got it. Still waiting to hear from Josiah and Kaylin if she's still here. And, of course, anybody else who's just kind of hanging around, let me know what you guys got. Okay. While we're waiting, okay, she had 2, 1, 1. Okay. If I had 2, 1, 1, it would look like this, right? So 2, 1, and 1. Okay. So that means I have 4 hydrogens here. I only have 2 hydrogens on the right. So right there is an issue, okay? That would force me to put a 2 here and get back to the right answer anyway. So just one minor step away from having the right answer. You just weren't finished. That's all. You're probably on the right track, but you just weren't totally finished. So I think this balancing stuff is not that bad, okay? I'm going to give you another one, all right? And then while you're doing that, Kaylin got it too. Good. What I'm going to do is I'm going to give you another one to try, just like what we just did. And while you're doing that, I'm going to see if I can come up with some sort of worksheet or list of questions where I can put this on Google Classroom, and we will go over that tomorrow during the live stream to get started. I think that's a good way to keep practicing and go from there. So let's give you another one. Let's try this one. Should I make it really difficult? Should I be... let's do that. Okay. All right, so you got C2H6 plus O2, and that's going to make H2O plus CO2. Try that one. I'm going to see if I can dig up a worksheet for you. I have some saved. And if I do, I can just put this up on the Google Classroom. And that will be a good way to continue. And we can kind of bring this to a close for today. To be honest with you, this is how I get most of my worksheets. Everyone's got the answer key. I feel kind of bad giving that to you. And again, I'm waiting to see if anyone's got it. All right, so you're trying this question on your own while I dig up a worksheet. Let me know if you get it. Nope, not that one. All right, I think I got something. So give me another moment. I will save this to my computer. And then once we're finished this video, I will put it up on the Google Classroom for you. Let's see. Okay. All right, so we got people saying they think they got it. Now, this one's not terribly difficult, but it's not exceptionally easy either. So let's start. We're going to go left to right, okay? And then before we finish, I'm going to give you 3 or 4 tips. I forget how many there are. I'm going to give you 3 or 4 tips to actually get through some of these. All right, we got... Okay, let's see what we have. We're getting some feedback. This is good. This is the way it should be. Thank you for everyone who's participating. Let's start from the beginning. I got 2 carbons, okay? And it looks like I have only 1 over here. So I'm going to start, and this might be wrong. We can go back and fix it. I'm going to put a 2 here, okay? Now, that means if I go back to the beginning, let's look. I have 2 carbons, 2 carbons. Good. I have 6 hydrogens, only 2. So I'm going to put a 3 here. That gives me 6 hydrogens on the right. Now, the last thing I got to deal with is my oxygens, okay? Now, I have 3 here, plus another 4. So that's 7 altogether. Now, there's not a whole lot I can put here to make this 7, okay? And this leads us to our next real tip, okay? If you get stuck, and I don't blame you for getting stuck on this one. This one's a little tricky, and I haven't taught it to you yet. If you get stuck, just stop and start over. But before you start over, put a 2 out front, okay? Put it double everything is what you're doing. So now this 2 here, so 2, I got 4 carbons. I need to get rid of that 2, and I'm starting over. I'm going to put a 4. Now that gives me 12 hydrogens on the left. So I need to get rid of this 3. I'm going to put a 6. If you notice, I just doubled it, right? 2 became 4, 3 became 6. Does that make sense? After I doubled this, I had to double these 2. Okay? Now, the last thing we got to worry about is your oxygens. I have 6 here, plus another 8. That's 14. Well, that's easy now. Put a 7. Okay? So the correct answer is 2764. That was a tricky one. Okay? Johnson, is that what you got? You said you got it, but I don't have your answer in the chat. So let me know what you think. All right? Now, having said that, I'm going to show you 3 tips or 3 steps, okay? 3 things that you can do to get out of trouble or make this go a little easier. I'm just going to write them down on this paper here, okay? So here are your tips, okay? Number 1, if you get stuck, right? You stuck? Start over with a 2 out front. Now, very rarely would John, not even close. Okay. Did you at least see why the right answer is right? I want everybody to let me know that the right answer I just showed you makes sense. Okay. If it doesn't, we need to go over it again. But I do need to start closing this out. Anyway, first tip. If you're stuck, you start over with just erase all your work and start over with a 2 out front. Then you're going to go in there and try it again. That usually works. Okay, good. All right, get some confirmation that it makes sense. Number 2, we did this one earlier. Okay, you're going to balance your polyatomics as one piece. Balance polyatomics as one thing, because I forget how to spell piece. So you're going to balance the polyatomics. In other words, if you have a phosphate on the left and you have a phosphate on the right, don't balance phosphoruses and oxygens separate. Balance the phosphates. So it works. Trust me, it speeds things up, and it gives you less work to do. You end up doing more at the same time with less effort. All right, number 3. This is rare, okay? This is very rare. But every so often, when you have water, it might help if you rewrite it as HOH. It's rare, but that does happen every so often. And there might be another tip or so that we come across. But those are the 3 big ones. These are the things that I wish I were taught a long time ago. And I'm just giving this information to you so that you don't have to struggle through all the learning curves of figuring this out on your own. So that's that, okay? We're going to close it out in the next couple of minutes. If you guys have any questions, now's the time. But I do need to stop this in a moment because I got to get my computer all figured out with a new link for the other live stream I got to do, okay? So go to Google Classroom, and you're going to see a worksheet there. I want you to try that worksheet, okay? I'll put it up in the next few minutes. I want you to try that worksheet on your own without me, see what you can do. This is a very abridged version of the lesson. I get it. So you're going to do your best. Tomorrow I'm going to start the live stream by going over some of those answers. Just makes sense, all right? So you kind of have homework, but it's not going to be graded. I want you to give it a shot, all right? Okay, so that's that. No questions or anything that have been happening. I gave you some examples. I gave you a worksheet. I went through the whole lesson with some tips that you probably wouldn't have gotten otherwise. So that's that. All right, guys, thank you for everybody who attended, and I will do another live stream tomorrow at the same time, starting with the answers on the worksheet that you find on Google Classroom. All right, guys, thank you very much. Talk to you again tomorrow. Thanks.